Hello everyone, welcome back to my channel. As you all know that myself, I am Pratibha, pursuing my Bachelor of Engineering in Electronics and Communication Department at Sri Venkateshwara College of Engineering. In today's session, I am going to discuss about addressing modes and its types, which is related to the subject called Computer Organization and Architecture. Firstly, let us go through the introduction to addressing modes. Addressing modes are a set of rules and techniques used in the computer architecture to specify how the operands of an instruction are accessed. They also define the various ways in which the memory address of an operand can be computed or specified. Addressing modes play a crucial role in determining the flexibility, efficiency, and complexity of the instruction set architectures. Now, let us see the what are all the types of addressing modes are present. Firstly, first one is the immediate addressing mode, second one register addressing mode, direct addressing mode, indirect addressing mode, indexed addressing mode, relative addressing mode, and finally the stack addressing mode. Let us go through one by one. First, immediate addressing mode. In immediate addressing mode, it involves directly specifying the operand value within the instruction itself. The operand value is typically a constant or the immediate data. This module is useful for performing arithmetic and logical operations on constants or immediate values. The immediate addressing mode, it is useful and it to perform the functions such as arithmetic and logical operations, and it is only applicable for the constants or only for the immediate values. Second one, register addressing mode. Register addressing mode, it involves specifying the operand using a register. In register addressing mode, it involves the specifying operand which uses the register. The operand value is stored in a specific register and the instruction refers to that register indirectly. This mode is commonly used for fast access to frequently used data or for performing the arithmetic operations on the registers. The register addressing mode, it is widely used in some of the applications in order to fast access to the frequently used data or in order to perform the arithmetic operations on the registers. Third one, the direct addressing mode. In direct addressing mode, it involves specifying the operand using a memory address directly. When we come to the direct addressing mode, the operand is specified using the memory address directly. The instruction refers to the memory address where the operand is stored. This mode is suitable for accessing data from the fixed memory locations or for accessing variable in high-level programming languages. Firstly, the instructions such as opcode and address A is given to the memory. It contains the operand. Fourth one, indirect addressing mode. Indirect addressing mode, it involves specifying the operand using a memory address which is stored in the register. The instruction refers to the memory address which is stored in the register rather than directly accessing the operand. This mode is useful for accessing data structures or the arrays where the memory address of the operand is stored in the register, where the operand A and it is passed to the operand, then it can be stored in the memory. Next, indexed addressing mode. Indexed addressing mode, it involves specifying the operand using a base address and an index or the offset value. The instruction computes the effective memory address by adding the base address and index of offset value. This mode is commonly used for accessing element of arrays or for implementing the data structures like linked lists. Relative addressing mode. The relative addressing mode, it involves specifying the operand using a memory address relative to the program controller, which is commonly called as PC. The instruction computes the effective memory address by adding the relative address to the current value of the program counter. This mode is useful for branching instructions and for accessing data for instructions within a limited range. Next, finally, the stack addressing mode. It is the seventh type of an addressing mode. In the stack addressing mode, it also involves the specifying operand using the top of the stack. The operand value is pushed onto the stack or popped from the stack based on the instructions. This mode is commonly used for the function calls, parameter passing, and managing the local variables. Now, the comparison of addressing modes. Each addressing mode has its own advantages and disadvantages depending upon the specific application and the architecture. Some addressing modes provide faster access to data, while others offer more flexibility in addressing memory locations. The choice of addressing mode, it depends on the factors such as performance requirements, memory constraints, and the complexity of the instruction set. Let us see the addressing mode and the applications. First, immediate addressing mode. It is used to initialize register to a constant value. Direct addressing mode and register direct addressing mode. It helps to access static data and implement variables. Indirect addressing mode and register indirect addressing mode helps to implement pointers and pass arrays as parameters. Relative addressing mode. It helps in program location at runtime and in changing the sequence of instruction during the execution. Indirect addressing mode, it helps in the array and record the implementation. Base register addressing mode, it helps in writing relocatable code and handling recursive procedures. Auto increment addressing mode and auto decrement addressing mode, it helps to implement loops and the stacks. Conclusion. Addressing modes are essential for determining how the operands are accessed and manipulated in the computer architecture. Different addressing modes offers various ways to specify memory addresses and access data efficiently. Understanding and selecting the appropriate addressing mode is crucial in designing efficient and effective instruction set architectures. Thank you.